In this video, we will see the natural language processing NLP, an introduction to NLP, and so far we have been working with images and numbers. Now we will see how the textual data can be converted to the numbers and then it can be used in the machine learning. So let us start with a sample code. The first cell refers to the import. We are importing two important features of Keras preprocessing. The first is called tokenizer and the second is called paired sequences. We will see how these two works one by one. To start with, let us take some sample sentences. I have taken 4 sentences, random sentences related to dogs and cats. As you can see, the sentences are not in the proper syntax. Some of the characters are in the lowercase, like I in the first statement and D of do in the second sentences. So now you have 4 sentences and you are passing these 4 sentences to some mechanism where the sentences will be considered as the input, and the machine will try to label each word with a number. So each word of your sentence will be labeled and mapped with a number. Each unique word will be considered here, and you can do the same character level also. So we'll use tokenizer here, and you can refer the document of tokenizer at the given link. So for instantiating the tokenizer, you can use the tokenizer class, and there are multiple parameters. Right now we are using one parameter, which is OOV token. In OOV token we are passing the value OOV, where OOV stands for out of vocabulary. So the purpose of OOV is the words which are not defined in the sentences given as the input are considered as the words which are out of the vocabulary. So the program will create its own vocabulary based on the sentences we provided to it, and if there is any word which is not in the sentences given to that tokenizer, it will create a separate word called OOV, and all the other words which are not included in the vocabulary will be assigned the word OOV with some number. So after creating the tokenizer, you can fit the text on the tokenizer. So you are passing all the sentences which you have created to tokenizer.fit on text, and then it will map the words of these sentences to a particular number, and then the word index will be created, and this word index is something which we will see once we will run the cell. So let us run the code. Now you can see in the result that the words of all the 4 sentences are separated and each word has been assigned a number starting from 1. So your OOV, which is out of vocabulary, has been assigned a number 1. It means that any word which is not in the list will be considered as OOV. Then it has started assigning the number from the words like do, like, dogs, cats, is. So each word has a number and these are the unique words. So in your sentences you have 2 dogs. Here you can see only one instance of dogs. So it has first identified the unique words and then it has assigned the number. Another interesting thing is that it automatically works on the lowercase. So it converts all the sentences into the lowercase words. So this of your last statement is now converted to this in the small letters, and that's why it doesn't matter whether you use capital letter or small letter when you are working with the default tokenizer. And the another thing is the punctuation mark. So in the second sentence you have dogs and question mark. So it has removed the question mark and it can remove all the punctuation while it assigns the number to each word. So now you can see that each unique word of the 4 sentences have been identified. A number has been assigned to them starting from 1 till 15. Now let us see this words sequences. So far you have separate words and now you want to create a sequence of these words. So you already have sentences and now you want to create the sequences out of this numbers. So you are passing the sentences and you are calling the function text to sequences. Let us print all 4 sentence sequences. So once you print that, you will find different numbers there. So your first statement was I do not like dogs, and now after sequences have been created it becomes 7, 2, 8, 3 and 4. So 7 is your I, 2 is do, 8 is not, 3 is like, and 4 is dogs. So your statement which was I do not like dogs has now become 72834. Similarly the second statement has become 2934 and so on. So as the sentences are of different length, we have to fix the length of the sentence, and that can be achieved by applying the padding to each sentence. There is another library of Keras which is called pad sequences. So in this we are passing the sequences and then we are setting the parameter padding is equal to post, which will pad all the sequences where the length is less than the maximum length of a sentence by zeros. So let us see how it looks like with the sentence number 1, which is our smallest sentence with 4 words. As you can see, the largest sentence has 6 words, and now the sentence which had only 4 words has been padded with 2 zeros. If you see the largest sentence, which is sentence number 4, and it has the 6 words, so you can see that it does not have any zeros because it does not need to be padded, being the largest sentence in the group of the sentences. This is how the tokenizer and pad sequences can be used in the natural language processing. In next video we'll see an example of NLP with some real world data.